Okay, good afternoon and welcome to the Master of Engineering Information webinar. I'm Samueli, one of the administrators for the Masters of Engineering degree program. And before we get to the meat of the webinar, I do want to acknowledge our land grant acknowledgement. As a land grant institution, UCLA Samueli School of Engineering acknowledges the Gabrielino Tongva people as the traditional land takers of the Tongan-Var, which includes the Los Angeles Basin and the Southern Channel Islands. Next slide. For today's agenda, we're going to do a welcome and introduction, a program overview, which will include the areas of concentrations within the program, and a question and answer series at the end. However, we do have our wonderful Masters of Engineering colleagues that can answer some questions during the webinar. Just use your Q&A function to submit those questions during the webinar. And so without further ado, I'm going to go ahead and turn this webinar over to our illustrious Associate Dean and Master of Engineering Faculty Director, Professor Meng. Thank you.
Thank you, Shana, and welcome to the information webinar for the Master of Engineering program. Okay. First, I'd like to introduce the area directors. Okay, we have Professor Guy van den Broek for Artificial Intelligence, and Professor T.C. Cao for Autonomous Systems, and Professor John Cho for Data Science, Professor Eleazar Esken for Digital Health Technology, and Professor Bruce Dunn and Associate Dean for Green Energy Systems, and Professor Meni Srivastava for IoT Systems, and Professor Song Li for Translational Medicine. And later on, each of the area directors will talk about their specific programs. I'd just like to give an overall program introduction. So UCLA School of Engineering and Applied Science has just set up a new academic program called a Master of Engineering, and it's designed as a professional degree. Okay, so the primary focus or purpose essentially is to cultivate future engineering leaders who understand the technical, business, and management challenges in high-tech industry. So this is a 1 year, full-time on-campus program. We started in fall 2021. So for fall 2022, we will only have 100 spots available for this program. Okay. So it is a self-supporting degree program. And in terms of the degree requirements, it requires 36 units of upper division and graduate level courses. Okay? So which is the same as for all of the on-campus MS students in the school. Okay? So out of the 36 unit or 9 courses, okay, 5 courses are technical courses with a specific interdisciplinary area. And we also have 3 courses, 3 required courses in engineering professional development. Okay, so this is more business and management oriented courses. In addition, all the students will take a 4-unit Capstone project. I would talk more about Capstone project later. And the tuition and the fees for 2022 and 23 academic year will be $50,400, or it's $1,400 per unit, and plus some of the quarterly fees for all the students. And in terms of the admission criteria are the same as those set by the graduate division. And for 2022 application is now open, and the priority deadline is December 1st. Okay. And we do have a limited needs-based financial aid available. Okay, so very briefly about the admission criteria. So UCLA Graduate Division requires a minimum undergraduate GPA of 3.0. Okay. And we also need 3 letters of recommendation. Okay, for those who graduated within the last couple of years, so at least 2 of the letters are from your faculties and our instructors. Okay, and GRE scores are not required. However, for international applicants, okay, we do require TOEFL or ELTS scores, okay? And we do need a personal statement. Okay? And industrial experience is not required. Okay, so for 2022-23 academic year, we offer 7 interdisciplinary technology concentrations. So these include artificial intelligence, okay, and autonomous systems, data science, digital health technology, green energy systems, IoT systems, and translational medicines. So as you can see that, okay, the students enrolled in the program are able to take courses from different departments. Okay, so for example, if you are in the AI program, you can take courses in CS, in electrical computer engineering, and also in computational medicines. Okay, and again, each area directors will talk more about each specific programs. Okay. And the students in the program basically will take courses with others from several departments. Essentially, this is a mixed enrollment. In other words, students in the Master of Engineering program will take courses alongside with the on-campus MS students. This is just a simple curriculum. Okay, so we just use a data science as an example. Okay, so this is again a 1 full calendar year program. So we went through the 4 quarter all the way until the end of summer. Okay. And so for 4 quarter, you need to take a total of 12 units. Okay. So with 2 technical courses and 1 engineering professional development elective. And in the winter and the rest of the 2 quarters, okay, you need to take 8 units. Okay, so in the summer quarter, okay, you also need to register and to finish up the last engineering professional development elective plus the Capstone Project. Okay. And, all right, so these are just some sample courses for engineering professional development. Okay, so we are offering, for example, Engineering 200 on technical project management, okay, and Engineering 214, which is about management and leadership communication, Engineering 215 about entrepreneurship for engineers, okay, and we are also developing a new course on leadership and innovation. Okay, so as the program grows, okay, the new courses related to engineering professional developments will be added as well. So I mentioned that all students need to take a course on Capstone Projects. And so this is a E299, which is also a 4-unit course, okay? And so the idea essentially is that you will work as a group, it will be a group project. We'll have teams of 3 to 4 students work together and to do hands-on analysis, design, fabrication, or testing as appropriate. And the project topic will be selected by the course instructors based upon current trends in each technology concentration and on industry input. Okay, and we have a Capstone project coordinator, and his job essentially is to connect with different industry and to solicit the ideas for Capstone project. And currently, as far as I know, we have many potential projects from Microsoft, okay, from American Express, from AAA, from City of Los Angeles, and also many startups in and around Los Angeles areas. Okay. So essentially, we would like you to work on the Capstone project that will help you to synthesize and integrate the knowledge and skills that you learn throughout this program. Okay. And so by the end of the summer, you will need to turn in a final project report and also a presentation to the faculty capstone committees and the entire class. Right? And so no thesis is required for this program. Student advising, okay, we are very excited to report that we have Jen Park here as your graduate advisors. Okay? And so her responsibility essentially is provide input and advice on course requirements, academic and university policies, registrations, and so on. Okay. And also she will provide assistance with problems or difficulties that may arise throughout the program and guide you to the correct resources for further support from UCLA campuses. Okay. In addition to Jen, we also have several area directors. Okay, so the area directors will provide input and guidance, and in terms of your area of studies, the curriculums, and so on. And if you want to take a specific course which is not on the list, okay, and you will need to seek the approval from the area director. And so let me briefly summarize other ongoing support that we have for the Master of Engineering students. Okay. So we have a career placement advisor on board, and he basically will coordinate and connect with industry recruiters, okay, and to provide potential employment opportunities. Okay. And we will also have a multiple career event specifically just for the students enrolled in the Master of Engineering programs. Okay. In addition, we'll certainly work with the campus placement office to organize a different recruiting event to support the hiring options. Okay. So as I just mentioned, that the Capstone project, most of the project will come from industry. So essentially, the Capstone project will provide you with a good connection with potential employers. And also you were able to receive the real world career guidance. And so here are just a sample list of industrial partners that we have put together. Okay, and we also have a very strong industrial advisory board for the program. Okay, we have, for example, Northrop Grumman's, Aerospace Corporations, Google's, Xerox, HRL's, and so on. So the list is growing. Okay. So I'd like to turn it over to each area directors to briefly introduce each of the interdisciplinary technology concentration. First, I'd like to invite Professor Guy van den Broek to talk about artificial intelligence.
Thanks. Hi, everyone. So I'm here representing the area of AI, and I don't really have to tell you what AI is. It's been all over the news. But I'll try to tell you why UCLA is the perfect place to maybe study AI. So we have a really rich history of AI. So for example, the first time a Rubik's Cube was solved by AI algorithms was here at UCLA. We are the birthplace of probabilistic models in AI. We're the birthplace of causality. So we have this really long tradition in the field, combined with the fact that a lot of the new professors that have been hired in the last 5 years are all rising stars in AI, doing natural language processing, computer vision, deep learning. And so I would argue that UCLA is in some sense one of the best places in the world to study AI specifically. And then hopefully, combined with the management skills that you will learn here in the Master of Engineering program, you will really have a very strong combination of skills to go on the job market, and specifically also for Silicon Beach, all of the industry and startups here in LA that do computer science and AI. And so, yeah, I hope you will apply to the program, and I hope to see you here next year.
Thank you. So next, Professor T.C. Chao for the autonomous systems.
Good afternoon. I'm Professor T.C. Chao. I'm representing the area of autonomous systems. Autonomous system is in a way interdisciplinary that mainly involve from bringing mathematical algorithm to software and then to hardware realization. And so a typical very prominent example could be vehicles, electric vehicles, ground vehicles, autonomous vehicle, airplane, and so forth, and robots. And robots has so many different applications in manufacturing, in medical applications, and now more into agriculture as well. And also aerial platform like unmanned air vehicles. And all these are very prominent examples. And also infrastructures like smart grid and water distribution systems. And so from those examples I mentioned, you can see that there are many engineering background like mechanical, aerospace, electrical, and civil and chemical engineering, and that all fit into this. And of course, computer science could also fit into this as a vehicle of a software for realizing such type of physical systems. And so the program we sort of configure is very flexible for multiple majors, like what I mentioned, to be able to participate in this program. And so we expect out of that 5 technical classes, student would take 3 or more from sort of a core area, like in control systems, dynamic system and control, estimation, learning, adaptations, and optimizations, and embedded systems. And then maybe take additional 1 or 2, at least 1, that is sort of more in application of these areas. So for example, robotics would be a very obvious example application area. And then we also have other classes that cover infrastructures like smart grids and embedded systems and control systems as well. And so the in terms of the employment possibilities it could be applied to so many industry like what I mentioned. And if I look back to the sort of student that got hired into what industry in our area, that could be like manufacturing, semiconductor manufacturing, or conventional manufacturing, into automotive industries, into startup, because a lot of startup, they build hardwares and they need to have students that have the ability to bring from a concept, an idea, towards some prototype working systems.
Thank you. Professor John Cho to talk about data science.
Hello, everyone. My name is John Cho. I'm a professor in computer science department, and I'm also the area director for the data science. So the data science is really about how we can make sense of like all the data that we collect from everywhere these days. And the reason why data science became very popular recently was first because just a lot more data is being acquired and being made available from businesses, from science, from industry, from all these sensors. So all this data is available, and at the same time, so much more computational power and also a lot of advanced algorithms have been developed in the last decade to somehow get more sense out of it, how we can somehow understand that data better. So the focus of our data science program is to teach you how you can use these advanced tools and algorithms so that you can acquire the data, manage the data, and also analyze the data. That will be the primary focus of our data science program. And because it spans over many different disciplines, starting from traditional science like physics or mathematics or statistics, all the way through electrical engineering, computer science, it is spanning over so many different disciplines. It is close to impossible to really learn everything about data science. I personally, even though I have worked in this area for more than 20 years, I don't claim that I know everything. Right? So the focus of our program is really about learning the tools and understanding the tools so that you can actually be able to practice a good data science, be able to analyze the real world data using the available algorithms, available tools. So that will be the primary focus of our data science program. So we have 5 kind of recommended courses from computer science, and primarily from computer science and electrical engineering. That is, we think is a good sequence of courses that you can take to get the firm grounding in there. So if you're an aspiring data scientist who wants to know the basic tools, how to use them, and how they work, and why they work, and what is the theory behind it, I think this is definitely one of the best programs that you can take, at least within 1 year kind of a time constraint. So if you're, I hope I can see you this coming fall.
Thank you. Professor Elias are asking for digital health technology.
Hi, I'm looking forward to hopefully seeing you as well in the fall. The Digital Health Technology is a great program. Digital health technology is a really interdisciplinary field with contributions from computer science, bioengineering, electrical computer engineering, computational medicine, as well as with many colleagues outside of engineering in the School of Medicine, biology. And our program really provides opportunity to collaborate, interact with many people throughout the campus. And the focus is on digital health, including mobile health, health information technology, wearable devices, as well as personalized medicine. So this is a great program. It's a really nice environment here with very large number of faculty and courses to choose from. And we hope to see you join us in this year.
Thank you. Professor and Associate Dean Bruce Dunn on Green Energy Systems.
Good afternoon, everyone. My name is Bruce Dunn. I'm a professor in material science. And as Professor Yang just mentioned, I also serve as an Associate Dean for Research and Resources in the School of Engineering. But I'm talking to you today as the director of the Green Energy Systems program. Energy is highly interdisciplinary, and so our program is equally highly interdisciplinary. We have faculty from material science, faculty in courses in material science and chemical and biological engineering, biomolecular engineering, mechanical and aerospace engineering, as well as electrical engineering and civil engineering as well. And so, as I indicated, in our program, we have a number of different courses. We focus on various technologies which are central to the idea of green energy. To be sure, there's energy generation by solar, wind, and other renewable resources. There's energy storage systems, batteries and capacitors, and large-scale energy storage. There's also smart grid systems and also grid integration. Both are critical issues. And then finally, the more overriding issues of energy and environment. So I look forward to seeing most of you next year. And really, it's an important area that I look forward to growing this area with you. Thank you.
Thank you. Professor Mani Srivastava on IoT Systems.
Hi, good day, everyone. I'm a professor in ECE and CS, and IoT track is actually a new track which will be starting next year. So as many of you may know, UCLA is where internet started. Literally the very first computer which was connected to the internet and sent a message was out here from UCLA. Now, for decades, internet literally just referred to kind of your standard computers, initially mainframes, then gradually kind of our desktop computers and laptops and all. But in recent times, internet is rapidly evolving, where the nodes on the internet are no longer just your standard computers, but really physical objects embedded in which are computing, networking, usually wireless networking, sensing, and actuation capability. So IoT really refers to this new form of computing, which over the last decade really has gained tremendous commercial ramifications, particularly with sort of applications literally everywhere. Now, as kind of I'm implying, this really is kind of a logical conclusion of several trends in computing. Deep embedding, so as we are able to put things onto a single chip, we are able to put all these capabilities I mentioned into ever tinier devices, in fact, even within ourselves. A second is sort of cloud connectivity, which is sort of we can pretty much take for granted now that wherever on the planet you are, you may have connectivity, not just in the sense of being able to communicate, but literally interact with computers out in faraway data centers, or in fact, even in someone else's mobile or embedded device. And then finally, these are not simply sort of plain sort of let's embed a computer, but rather intelligently interact with the surrounding environment and both not just humans, but also the physical world, to sense them, to nudge them, to control them in a variety of ways. So that's the capability we have, and this track is really about exposing you to both fundamentals and applications of this new generation of computing. Now, UCLA is the perfect place for it in a way. I alluded to it being the birthplace of internet, but also we have been really well known for work in wireless networking and mobile computing. Single chip CMOS radio literally came out here. In fact, our school is named after Professor Samueli from ECE department, who was one of the co-inventors of that while he was here at UCLA. And another more recent thing is wireless sensor networks, where we had the first international sensor. Literally the phrase and the book on this was written by faculty at UCLA. So IoT track is really kind of at the right place in that regard. Our track is organized around kind of three core things which go on to build IoT. One is that the intelligent interaction. So it is AI and ML methods, but particularly focused on spatio-temporal data that sensors give and which you need to interact with actuators. Second area is connectivity, particularly wireless connectivity, because that's where IoT becomes particularly interesting. And the third one, of course, is the ability to embed computing. And by that, I mean running in all this stuff in kind of very resource constrained kind of a setting in a single chip or on a microcontroller and all. So those are 3 core tracks, and the track, 3 core course of this track. And the curriculum requires you to take at least 1 course on each one of these. And then after that, we give you, you can explore in depth where your interest takes you. There's a bunch of courses which are cross-cutting, so they touch upon things like security and human factors and application domains which are important. And then hopefully the project kind of leads you to explore all these concepts in context of a concrete system. So that's all I have to say. Thank you.
Thank you. Professor Song Lee on translational medicine.
Hi, good afternoon. My name is Song Lee. I'm a professor in the chair of bioengineering department. I also serve as the director of translational medicine track. You probably know translational medicine is really a highly interdisciplinary field at the interface of engineering, biological sciences, and medicine. So this area really integrates the faculty expertise in many departments. In engineering school, it includes Department of Bioengineering, Chemical and Molecular Bioengineering, and Computational Medicine. In addition, we also involve the faculty in the School of Medicine and School of Dentistry. Furthermore, we also have extensive support from our industry advisory board members, and they work in either device or pharmaceutical companies in California. And you may ask, translational medicine is really broad field, and there's so many things that we can work on. And what are the major topics we cover? And here I want to give you 3 examples. The first one is therapeutics development. For example, you will learn something on drug delivery or engineering stem cells for regenerative medicine. In the second area, here is diagnostic tools, where that includes portable device, such as wearable electronic device for monitoring. It could be a point of care device for diagnosis, or even traditional instrumentation, for example, biomedical imaging. In the third area is that interface of data science in biomedical applications. For example, systems biology and computational biology. So overall, we have many technical elective courses that could cover these areas. You may also find some other interesting topics, for example, FDA regulatory issues, startup entrepreneurship related courses. I look forward to talk to you if you have more questions.
Thank you. Okay. We do have a website available for the program. It's meng.ucla.edu, or you can email us if you have any questions. All right, so let's open the Q&A session.
Dean Yang, there are a few questions that we wanted to answer live. For the 9 classes, it's understood that for our professional development classes, for the 5 classes, do we have to take classes all within the same area of study, or will there be opportunities to take electives in another area?
Okay, you are only required to take 3 business management courses and 5 technical courses. And so the 9th course is a capstone project. So in terms of the technical courses, Okay, as several area director mentioned that we would like to keep it as flexible as possible. So if you would like to take courses outside your specific program, please consult with the area director, as long as you can show the relevance of the course in terms of your career goals or the specific areas that you are interested in. I believe we basically will approve it. Okay.
Perfect, thank you. Another question is, what is the maximum time to degree for the program? And will there be any opportunities to submit a leave of absence during the one-year program?
Okay, so the official degree, the limit essentially are 6 quarters, so 2 academic years. And so ideally, we would like you to finish the degree in 1 calendar year, okay? But the campus do allow you to take up to 2 quarters of leave of absence.
Perfect. This directly relates to the digital health technology or in translational medicine. Will students in the MEng program have the opportunity to take technical classes from other UCLA graduate programs, such as the School of Public Health or School of Medicine?
Professor Lee and Professor Askin, would you like to chip in?
Yes, in translational medicine track, we do have instructors in medical school to teach courses on biomedical imaging. And also there are faculty in other departments who teaches courses on computational biology and systems biology as well.
Yeah, same answer. In our track, there's many opportunities for taking classes taught outside of engineering and by instructors in other schools. In fact, actually many of the classes themselves that are listed are cross-listed. So they're both in the Geffen School of Medicine as well in the School of Engineering.
Thank you.
Great. Will there be any opportunities to audit courses through UCLA Extension before officially enrolling in the program?
I don't believe there's a mechanism that you can audit the course through UCLA Extension, but you can take UCLA courses concurrently through UCLA Extension. If there is any specific course that you would like to audit, please let us know so that we can communicate with the instructor of that specific course to seek their input and guidance.
Okay, so does the program accept applications that already have a master's degree in a related field? And would it be possible to participate in a summer internship and take the Capstone course in a second fall semester?
So, sorry, what is the first question?
I can repeat it. No problem. Does the program accept applicants that already have a master's degree in a related field?
Well, I think per UCLA graduate division's regulations, you cannot get a second MS degree in the same field, meaning like if you have a degree in electrical engineering from other institution, you will not be able to get another degree in electrical engineering at UCLA. But since it's a Master of Engineering degree that we offered, and the answer is yes.
Okay. Would it be possible to participate in a summer internship and take the Capstone course in a fall semester or fall quarter, excuse me?
It's possible. However, the Capstone project is a group project. Okay? And so the majority of the work may be done during summer. So if you would like to take the summer internship, you need to coordinate with your group mate in terms of your contribution and your assignment. And hopefully that when they are doing their presentation, you will be available to participate as well.
Perfect. This is specifically for autonomous systems. Could you still apply to the autonomous systems program without an intensive, coding background?
Professor Cao?
Sorry, could you repeat the question?
Sure. Could you still apply to the autonomous systems program without an intensive coding background?
Well, we expect students having at least one programming class because that's a requirement for virtually all engineering degrees, in all engineering bachelor degrees. So we expect students have some coding experience from at least one class. And it's hard to define what is not significant coding experience, but we expect students have taken classes related to programming and have that exercise, because that is, as I understand, that is pretty much the requirement for virtually all engineering majors. Yeah.
Thank you. Are there any opportunities to work on campus while completing the Masters of Engineering program? For example, a teaching assistant, research assistant, et cetera.
Okay, the answer is yes. If you are able to get a TA for the on-campus undergraduate courses, you are certainly qualified to be to serve as a TA. For research assistantship, you need to work with each individual faculty members.
Since the Masters of Engineering program is designed to be an entire calendar year, will we be able to walk in the spring, or do we have to wait until the following year to walk since a summer quarter is required?
That's a very good question, in fact.
I do know that for other programs, the students can walk if they are set to graduate in the summer.
I would think so. However, I need to double check with the school, okay, to make sure that our students will be able to walk by the end of the spring quarter. That's a very good question. Yes, I need to check.
And for those questions that we may not have gotten to, feel free to email us at the MEng@seas.ucla.edu. I'll also place that in the chat as well. Okay, let's see. May I know if the IoT track will have any courses that focus on industrial or smart manufacturing? So this is specifically for the IoT track.
Sure. Yeah, let me take it. So firstly, the core course, one of the core courses that we require for embedded computing does cover kind of the industrial applications, but more importantly, one of the courses from MAE taught by Professor Rajat Garg, which would be available as an elective, does go into some smart manufacturing aspects of IoT as well. So short answer, yes, across a couple of courses, you do see coverage of that. And additionally, many of our other courses are project oriented, and it's very common for students to do projects which explore these kind of applications, particularly industrial, with a focus of industrial and commercial aspects. So hopefully that answers, but would be happy, reach out to me and I'd be happy to provide more details.
Perfect. For an undergrad who did not do a computer science degree, are there prerequisites to enter courses such as data science and AI? Can these prerequisites be completed through online platforms such as Coursera?
Professor Cho?
Yeah, in principle, yes. So one of the important kind of prerequisites for data science, and probably for AI as well, there are some basic probability and statistics courses that you have to take, and also some courses on linear algebra. Those are kind of key mathematical foundation. And also we do expect that students have some programming background as well. So if you lack in any of these kind of areas or the topics or the classes, then definitely it is a good idea to somehow meet that prerequisite in various ways. And taking good online courses like Coursera might be a good option. But one thing that you want to make sure is that if you're serious about applying to UCLA and then somehow use these online courses to actually meet the prerequisite in some sense, is to somehow confirm that the quality of those classes somehow meet the kind of expectation that you have. So as long as they are reasonably good courses, I'm sure you can actually build the foundations and meet the prerequisite that way.
Professor Van den Broek, any additional input?
No, I agree with what Professor Cho said. So we often make exceptions for people that have this background in some way. But of course, it really depends on the course and on the instructor. But it's very common for people to have that background through other means, yes. And it's usually background in basic probability, basic programming, kind of basic computation. And so, yeah, that's usual that there are some exceptions made.
Thank you.
Thank you. Does this program meet the OPT requirement? Also, does the school offer any co-op programs?
Okay, yes, the program meets OPT requirements. Okay, so OPT requirement essentially is that you need to attend the program for at least 3 quarters in a row. Okay, so the program meets OPT requirements. And we don't offer this so-called co-op program, but the idea of Capstone Project essentially is more or less similar, okay? And we will connect you with industry, okay, to work on the real problems, okay? And hopefully that experience will also help you to connect with all the potential employers.
Are there any plans for a remote cohort? Recognizing that the benefits of are being in person, but still trying to figure out logistics.
This is designed to be a 1-year on-campus program. So we do, but for 2021, okay, due to the challenges from the COVID, and some of the courses are offered online, but in order for you to meet the OPT requirements, you need to take a minimum of 1 on-campus course per quarter. Okay.
Perfect. Let's see. As far as the data science track, what will an ideal candidate or applicant look like for data science?
I would say essentially the classes, like who are the training in the classes that I just mentioned. So the exact tools that you will use for data science, you will learn that from our program. But in order to learn those tools and theory, you need the basic background. So what are the basic background? The first one is mathematical background, which is probability, basic probability, statistics, and the linear algebra. These are the classes that you will take in any undergraduate, either science or engineering program. So as long as you took them and then you are familiar with them, you're confident about all those kind of subjects that we cover there, that'll be good. One more additional thing that we also require is some familiarity with the basic programming and also some of the algorithms, like algorithmic aspects. So as long as you have these two, so you don't really need like computer science kind of a level or major level kind of a requirement for the programming, but we do expect that you are comfortable doing programming in your chosen language. And the language that we use most often in our data science curriculum is Python. So if you are a reasonably good Python programmer, and also you feel comfortable like looking at the code or looking at the algorithms and understand it, that will be really the ideal candidate for our program.
Thank you.
Are UCLA Anderson professors involved with the engineering professional development courses?
We do work with some of the instructors from Anderson to teach courses for us. For example, I think in fall 2021, we have Professor Bob McCann to teach management communication. He basically teaches the same course for Anderson.
Great. So are there any scholarships available for international students?
We do offer limited scholarship to our students. However, it's very competitive. So it's open to all all candidates.
Great. So this question is specifically for AI. Again, could we take specific topic course, knowledge representation and reasoning in AI as part of the Master's of Engineering AI degree, or only those as per the school recommendations?
Yeah, so these special topics courses, 269, they are, some of them are also available this year to the students. Of course, these are more specialized courses, so you have to check that your background is the right background to take them. But I think otherwise we're open to that. Yeah.
And so a similar question, what would be a ideal candidate for the green energy systems? What would an applicant for that program look like? Would a background in aerospace engineering be eligible?
Would you like me to take that one, Meng, about green energy systems?
Yeah. Well, again, the green energy system, just like several other areas, are highly interdisciplinary in nature. So the students with aerospace engineering degree certainly is eligible. But you may need to beef up some backgrounds in material science engineering in order to take courses related to energy harvesting and energy storage. Okay.
Great. So it looks like most of our questions that we're going to answer live. Oh, there's another one coming. So what is the expectation and prerequisite from an ideal candidate for AI look like?
Professor Van den Broek.
Yeah, I mean, it's a difficult question, of course. People enter the field of AI from all sorts of backgrounds, right? So there's a kind of traditional track of, a computer science background. There's also a traditional kind of statistics or even physics background where people go into AI. So, especially for AI, it's very difficult, from signal processing. In AI, there's always been this cross-fertilization with even, philosophy, psychology, neuroscience. So I don't think there is such a thing as an ideal AI background. Of course, if you have a strong academic record, that's what we're definitely looking for. And strong motivation as well, right? Those types of things that are generally true. Yeah, I wouldn't say there's like one profile of a good AI master's student.
Thank you. Can students also take a few more other technical graduate courses in addition to the 5 technical courses in the track?
Yes, you can. However, you need to be aware of the fact that we charge tuition based upon the number of units you take. Okay, so if you would like to take additional courses, you need to pay additional tuitions as well.
Perfect. Okay, so we're still kind of manning the chat at this time. We're going to actually conclude our webinar. If you have any additional questions, we're going to be on the Q&A for a little bit to answer some questions. Again, if you have any additional questions, you can definitely email us again at our email address, meng@seas.ucla.edu. Dean Yang, do you have any closing remarks?
Well, thank you to all of you, okay, including all the area directors. So please feel free to contact us if you have any additional questions. Okay.
Perfect. We'll also be updating the frequently asked questions addressed in this webinar on our website as soon as possible. So also check our website, meng.ucla.edu, for the frequently asked questions, which will be regularly updated. Okay, thank you.